Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express U channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are wrapping up our 5th week of our 9-week course. On Monday, we will not be broadcasting as it is Thanksgiving here in Ontario, so there will be no classes. Our classes will restart next week on Tuesday, October 11th, so have a great long weekend. At this point, as we are halfway through the course, you really should be thinking about what work you will be submitting for marking. Reminder that the key questions, the ones with the little key icon, are listed at the end of each lesson, and they tell you what questions you need to be submitting. So do all of them. Some of them are check your understanding questions, some of them are activities, and some of them are review questions. Explain all of your ideas, your thoughts in complete sentences to really give us a full understanding of what it is that you understand, and make sure you're actually answering the question that is given. You can do this by hand or electronically. If you're going to write in your workbook, that's totally fine. It is yours to keep, but the spaces are pretty small, so I'd strongly encourage you to write your answers on a separate piece of paper to send in. If you're going to do it electronically, please, the PDF files, Word and Google Doc files are the easiest for us to open, so send it in those if you can. Everyone has access to Google Docs through their NNEC email address. Let us know if you need us help to figure out how to access those. If you need to use a different file type, most likely it's fine. Just let us know so that we can make sure we can actually open it. So then how do you submit your work for marking? Well, there's 3 methods. The first method is to send your work in electronically. You can scan your completed work if you did it by hand. If you have a device, Apple devices have the Notes app that has a scan function, and Android devices have a Google Drive app that also has a scan function. If you need to just take pictures with them and send those, we can totally deal with that. Just scanning them makes the file smaller and a little bit easier for us to deal with. Then send it to us through email to studentwork@nnec.on.ca and CC it to John. John is now the marker for this class. I continue to instruct for the remainder of this term, but after the beginning of November, John is the one who's responsible for this course completely. So send him your work. His email address is jstradiotto@nnec.on.ca. You can also drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. Just put it in there and we'll get it back to you as soon as we can. Then the third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work if you have access to a fax machine. Though I am not marking the work at this point, and I will not be responsible for the course after November, you can still connect with me through Facebook and subscribe to my YouTube channel if you want access to all of our videos. All of my videos will continue to be up online. I'm not taking them down, even though I'm no longer responsible for the course. They're still there, so you can still have access to them. Remember, they're under a playlist called SVN3E, and I do share them on Facebook, so that can be an easy way to access them if you need to. Science is really visual. I incorporate lots of videos, diagrams, charts, illustrations, graphics in my lessons to really make it help us understand what's going on. So I strongly encourage you to access the videos, either joining me live through Zoom or watching the YouTube videos on your own time. If you don't have reliable internet and neither of these options are available to you, let me know and I'm happy to send you a copy of the videos so that you can still access them. All right, so if you do have any questions or concerns, please reach out to us. You can still connect with me if you would like to, though John is the course marker, and so it would make sense in terms of actual answering questions and such to talk to him. But you can email me at bronwyn.slate@nnec.on.ca or connect with me through Facebook at bslatewahsa. You can email John at his email address, which is jstradiottto@nnec.on.ca. You can call us both on the local number at 807-737-1488 or the toll-free number at 1-800-667-3703. My extension is 2209. John's extension is 2210. You can connect with either one of us. John's office hours are Monday through Friday, 8:30 a.m. to 3:30 p.m. And he takes lunch from 12:30 to 1:30, so isn't available during that time. It's important to me to position myself within the context of this course to recognize that there are systemic barriers within education. I have white settler ancestry, I have white privilege, and this has shaped my experience of education, both when I was a teenager in our public education system and also when I went to university and began learning to be a teacher. So I recognize that my experience of education is easier and had less barriers than many other folks. So though I cannot change my past experience nor the past experiences of other folks, I work to dismantle this system and be part of that process to make education more equitable and accessible to all. I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people and consistently work to integrate cultural knowledge and representation into our courses, though this is a work in progress and something that I don't have completely figured out. I have lots to learn and unlearn, both as an educator and just as a person, and so I'm committed to this journey, but it isn't something that happens instantly. Our textbook is also problematic. I found that it's very Eurocentric, centering the experiences of white communities and white scientists and their knowledges, and ignoring Indigenous, Inuit, Métis, and Métis knowledges and experiences. This is concerning and problematic, though I have not been able to find another resource. And once I am no longer responsible for this course, once November comes, that isn't something that I could necessarily change, but it is something that is important and we will continue to talk about within our programming. All right, so we are continuing with Unit 2 today, which is using energy in our lives. We talked about renewable and non-renewable energy sources in our previous lesson, and today we are going to talk about the costs and benefits of using different energy sources. So this is lesson 14. So our learning goals are that at the end of this lesson, you will be able to discuss the environmental costs of generating power using nuclear, coal-fired, and hydroelectric generators, and you will understand the advantages and disadvantages of several alternative generation strategies. You know you've met those learning goals because you know the cost, extraction, and use of coal, natural gas, and nuclear energy, and you can explain the benefits and challenges of wind, hydroelectric, and biofuel power. So we're looking both at non-renewable and renewable energy sources and both the costs and benefits of them, because nothing's simple and perfect. So as I was just saying, non-renewable and renewable energy sources all have costs and they all have benefits. So we need to consider the financial costs, the availability, and the environmental impact when thinking about the pros and cons of various sources. So we're going to focus on two examples. For every situation, there are different costs and benefits. So we're not going to look at every single one, but this is just an introduction to how there are different costs and benefits to both renewable and non-renewable energy sources. So first, let's look at what the major fuel sources are in Ontario. So Ontario's power grid is based on various energy sources. So we've learned how the environmental costs of burning fossil fuels as it releases carbon dioxide, nitrous oxides, carbon monoxide, hydrogen carbons, sulfuric dioxide, heavy metals, and other pollutants into our air, soil, and water. We've been talking about that pretty much the entire course. So historically, coal is the cheapest fuel for generating electricity. As a result, many generators in Canada are designed to burn coal. So shutting down plants and changing them so they can use different energy sources can be expensive. This is part of the barrier of stopping to use coal. But as of 2014, Ontario no longer uses any coal to generate electricity. So we have 8 years that Ontario has stopped using coal to generate electricity. So here's a graph that shows where we get our energy for our power grid in Ontario. So in 2003, coal was 25%. Now in 2000, so according to this information, so not now, but 10 years later in 2014, 0% was used by coal. So how did that get shifted? So in 2003, in terms of renewable energy that wasn't hydro, wasn't water, there was 0%. And then in 2014, it is 7%. Hydro only went up 1% from 23% to 24%. Gas went down from 11% to 9%. So another non-renewable energy source went down, and nuclear went from 42% to 60%. So the majority of it went to nuclear power generation with some other renewable energy sources. So approximately 94% of the electricity generated in Ontario in 2019 was emission free. So nuclear energy, though non-renewable, is emission free. It doesn't contribute to the pollution in the air, doesn't contribute emissions. And so between nuclear energy, hydro energy, and other renewable energy sources, 94% of the electricity generated in Ontario in the past few years was emission free. So we are definitely starting to work on this. This is an important issue and we are making change. But they all have costs. So this is beneficial, but there's still other costs. So let's just look at other than coal, right? Because coal, we've decided, we know there's lots of costs to coal, but let's look at the cost of other fuel types as well. So natural gas, it's cleaner than burning coal, but it still produces greenhouse gases. The process of refining natural gas destroys wildlife and habitats. So that process of extracting and making it so that we can use it isn't good as well. More and more, it's becoming difficult to find natural gas reserves, meaning it is becoming more and more expensive. Natural gas used to be super cheap and it was a great way for the public a great resource, but as it's becoming rarer and rarer, it's becoming more and more expensive. So this graphic shows you that the annual cost of heating a 2-story 4-person house in 2006 with natural gas was $1,618. And then it went down, progressively going down. And in 2012, it was $924 to heat the same area. But now at 2014, when this graphic was made, it was back up to $1,183. I don't know where it is now, but potentially it's gone up as well. Probably most likely it's gone back up. Okay, so now let's look at nuclear energy. So Canada is now the world's second largest uranium producer, behind Kazakhstan since 2009. In 2016, Canada's share of world uranium production was 2%, worth about $2 billion. More than 85% of mined uranium in Canada is exported. So though we are using it primarily in Ontario, we're using it more and more significantly, we're still exporting a lot of our uranium. We're making a lot of money off of it. There are 19 CANDU nuclear reactors in Canada, 18 are found in Ontario and 1 in New Brunswick. It's cleaner than other fossil fuels power, as nuclear reactors do not emit the pollutants that contribute to global warming, acid rain, or smog. So it is a clean, in terms of that context, it is a clean fossil fuel, though it is still a non-renewable source of energy. Nuclear power plants, however, are expensive to build and to maintain. Mining uranium emits carbon dioxide, nitrogen oxides, VOCs, particle matter, and sulfur dioxide. The waste from uranium minings and nuclear power generation also is dangerous, and difficult to dispose of and store. So right now there's been last few years, there's been a proposal put in place to have a nuclear waste containment center in Ignace. And so there's been a lot of conversation in Northwestern Ontario in terms of this. Is this a good idea or not? It's not what I wanted. So we're going to look a little bit at that information to see. Now, we're not going to watch this whole video just because we don't have time. We're going to watch a bit of it and understand a little bit about what is going and the costs and benefits of having this nuclear waste plant in.
The goal being to determine if the underground...
Just trying to get...
The nuclear... The Nuclear Waste Management Organization is pitching the locals the DGR concept, which involves entombing used nuclear fuel for 250,000 years plus in the Canadian Shield. Outside of town, the NWMO is busy drilling boreholes. The goal being to determine if the underground rock here is right for a $23.6 billion nuclear crypt. If the DGR gets the go-ahead, it could be very good news, economically speaking, for a township that for decades has been in decline. But not everyone is happy about the plan, including this local Ojibwe man who met APTN Investigates in the parking lot of the Ignace Shopping Plaza where the NWMO has its offices. He was there for a demonstration against the NWMO's plan, but no one else showed up.
My name is Roy Ignace, and you might think that because this is Ignace that I'm the mayor or something like that. I'm not.
He's a funny guy who also speaks plainly about what he thinks of the NWMO's proposal. Why do you think they picked this place?
Because it's remote, you know. They figure, well, less people over here, the less people to fight or to argue. The whole thing will fail. It might take, 1,000 years, whatever, but it will fail. Because no matter what kind of a container, no matter how solid that container you put into the ground, sooner or later, it will rot and it will break. And whatever is in it will spread. You take a look at the swamps around here. There's water there. And one way or another, that water finds its way into a river system.
Northwestern Ontario has a way of working itself into the souls of the people who live here. Donald Cunningham is mayor of Ignace.
I was born and raised in Northwestern Ontario. I lived as far east as Thunder Bay, but remained within the Northwest region to enjoy the fruits of the Northwest region.
But love for a place doesn't make the economy run, he says.
Well, in the last 30, 35 years, it's been, the mines closed approximately about then, and it's basically hadn't really recovered economically. It's gradually, it went from approximately, 2,500, 3,000 people to the present 1,200 people. And still 1,200 great people, but now the new administration and leadership and stuff is endeavoring to work at revitalizing the area, getting it, help getting back on its feet and moving forward economically and socially.
Mayor Cunningham is hopeful the proposed $23.6 million deep geological repository project could help turn things around.
Personally, I look at it as a great opportunity for our youth, which are instrumental. It creates an opportunity for stability for the community.
And as well as a potential major surge in Ignace's economic fortunes if the DGR goes ahead, there is also funding flowing into Ignace from the NWMO now, just for considering the project. Communities engaging with the NWMO sign what is called a Learn More agreement. With that agreement comes funding for the community to, among other things, educate itself on the DGR concept. In total, since 2010, the NWMO has spent more than $3 million in Ignace, whereas the municipality of South Bruce, the other area being looked at by the NWMO as a possible DGR site, has received over $2 million. In each of those communities, $1.2 million of those totals have been for what's called community well-being. That money is to invest in things such as refurbishing a community arena or improving a local library. Within the Ignace area, there are 7 First Nations the NWMO is engaging with as well. We were invited by band members at the Ojibwe Nation of Seguin to head up that way. We did that, and we met with Nisha Dupuis. Dupuis doesn't pull any punches when it comes to her characterization of how things are run on reserve.
We've been living under dictatorship for over 31 years. We have a self-proclaimed chief who took the names of people from different communities and made his own ban list with the promises of making a better place, a better community for the people of this area. And he still hasn't fulfilled those needs. Needs of good housing, education, employment opportunities, training opportunities. There's so many things that we have been promised and have never received.
You may have heard about the ongoing issues in Dupuis' community. Some members of the band are trying to oust Chief Edward Mashimity, who governs without having to seek re-election. Thanks to the band's governance code, Edward Mashimity could potentially be chief for life. APTN Investigates did reach out to band leadership by phone, text, and email. We were looking for information on how the band is keeping members up to date on the NWMO, but we got no response. The NWMO does have a Learn More agreement with the Ojibwe Nation of Seguin, and a band member has been hired as a liaison to keep people informed about the NWMO's proposal. But in spite of that, Nisha Dupuis feels that band members are not aware of what's happening with the NWMO. So we went with her into the Ojibwe Nation of Seguin Reserve. And while she did some door knocking to raise awareness about the NWMO's interest in the area, APTN Investigates had a chance to question some of the residents. Have you heard anything about the Nuclear Waste Management Organization?
No, I've heard nothing yet.
I'm trying to find out if people know about the NWMO in this on reserve. You heard anything about the... No?
No, never heard nothing.
Okay. How about you, ma'am?
No, I've never heard nothing either.
Okay. There's someone in the community who works for the community who is supposed to be telling people about what the NWMO wants to do. Have you heard anything about
nothing.
that?
They don't tell us nothing.
Okay.
All right, so I'm going to pause the video there just because we don't have enough time to watch the whole thing and do everything else that we need to do. But I will link it in our show notes to see, so you can watch it all if you want to, just in terms of getting the multiple sides of this issue, because it really is complex. I also just want to show 2 more little videos that are just show how complex this issue is, and to help not be biased in terms of one opinion or the other opinion, but to help just inform folks about the challenges and the benefits of nuclear energy. So we're going to watch this first video, which is 3 reasons why nuclear energy is terrible. Hopefully it's going to work for me.
3 reasons why we should stop using nuclear energy. 1. Nuclear weapons proliferation. Nuclear technology made a violent entrance onto the world stage. Just 1 year after the world's first ever nuclear test explosion in 1944, 2 large cities were destroyed by just 2 single bombs. After that, reactor technology slowly evolved as a means of generating electricity, but it's always been intimately connected with nuclear weapons technology. It's nearly impossible to develop nuclear weapons without access to reactor technology. In fact, the Nuclear Non-Proliferation Treaty serves the purpose of spreading nuclear reactor technology without spreading nuclear weapons with limited success. In 40 years, 5 countries have developed their own weapons with the help of reactor technology. The fact of the matter is that it can be very hard to distinguish a covert nuclear weapons program from the peaceful use of nuclear energy. In the 1970s, the big nuclear powers were happily selling peaceful technology to smaller countries, which then developed weapons of their own. The road to deadly nuclear weapons is always paved with peaceful reactors. 2. Nuclear waste and pollution. Spent nuclear fuel is not only radioactive, but also contains extremely poisonous chemical elements like plutonium. It loses its harmfulness only slowly over several tens of thousands of years. And there is also a process called reprocessing, which means the extraction of plutonium from spent nuclear fuel. It can be used for 2 purposes: to build nuclear weapons or to use it as new fuel. But hardly any of it is used as fuel because we don't have the right kind of reactors for that. A milligram will kill you, a few kilograms make an atomic bomb, and even an inconspicuous country like Germany literally has tons of the stuff just lying around because reprocessing sounded like a good idea decades ago. And where will all the waste go? After dumping it into the ocean was forbidden, we've tried to bury it, but we can't find a place where it will definitely stay secure for tens of thousands of years. Over 30 countries operate nearly 400 reactors, managing several hundred thousands of tons of nuclear waste, and only 1 is currently serious about opening a permanent civilian waste storage: tiny Finland. 3. Accidents and disasters. Over 60 years of nuclear power usage, there have been 7 major accidents in reactors or facilities dealing with nuclear waste. 3 of those were mostly contained, but 4 of them released significant amounts of radioactivity into the environment. In 1957, 1987 and 2011, large areas of land in Russia, Ukraine and Japan were rendered unfit for human habitation for decades to come. The number of deaths is highly disputed, but probably lies in the thousands. These disasters happened with nuclear reactors of very different types in very different countries and several decades apart. Looking at the numbers, we may as well ask ourselves, are 10% of the world's energy supply worth a devastating disaster every 30 years? Would 30% be worth another Fukushima or Chernobyl somewhere on Earth every 10 years? What area would have to be contaminated so we say no more? Where is the line? So, should we use nuclear energy? The risks may outweigh the benefits, and maybe we should stop looking into this direction and drop this technology for good. If you want to hear the other side of the argument, or a short introduction.
All right, so that's the one side. The other side is 3 reasons why nuclear energy is awesome.
3 reasons why we should continue using nuclear energy. 1. Nuclear energy saves lives. In 2013, a study conducted by NASA found that nuclear energy has prevented around 1.8 million deaths. Even if you include the death tolls from Chernobyl and Fukushima, nuclear energy ranks last in death per energy unit produced. While nuclear waste is really toxic, it's usually stored somewhere, while the toxic byproducts of fossil fuels are pumped into the air we breathe every day. So, just by reducing the amount of fossil fuels burned, countless cases of cancer or lung disease and accidents in coal mines have been avoided. If we can choose between lots of dangerous stuff being put into a deep hole and lots and lots and lots of dangerous stuff being pumped into the atmosphere, the former seems more logical. Nuclear energy feels way more dangerous though. Single catastrophic events burn into our memory, while coal and oil kill silently. It's like the death rate of flying versus driving. Even in the best case scenario, it would take at least 40 years to switch to 100% renewable energy. So for as long as we continue using fossil fuels, nuclear energy will save way more lives than it destroys. 2. Nuclear energy reduces CO2 emissions. Nuclear energy is arguably way less harmful to the environment in terms of climate change than fossil fuels, our main source of energy. Since 1976, about 64 gigatons of greenhouse gas emissions have not been pumped out thanks to nuclear energy. And by the mid-21st century, that could amount to an additional 80 to 240 gigatons. Humanity's energy consumption is rising steadily. According to US government projections, China alone will add the equivalent of a new 600 megawatt coal plant every 10 days for the next 10 years. China already burns 4 billion tons of coal each year. Coal is cheap, relatively abundant, and easy to get to, so it's not likely that humanity will stop using it soon. Nuclear energy might be the only way of dampening the effects of climate change and preventing a catastrophic man-made global warming. Compared to the other things we do, nuclear energy is relatively clean. So even if it is a good idea to quit nuclear energy long-term, it might be a good solution for the next 100 years or so compared to the alternatives. 3. New technologies. Maybe technology will solve the problem of nuclear waste and dangerous power plants. The nuclear reactors we've used so far are mostly outdated technology because nuclear innovation stopped in the 1970s. There are models like the thorium reactor that could solve the problem altogether. Thorium is abundant, really hard to turn into nuclear weapons, and up to 2 orders of magnitude less wasteful than current nuclear reactors. The waste material might also be only dangerous for a few hundred years, in contrast to a couple of thousand years. 1 ton of thorium is estimated to provide the same amount of energy as 200 tons of uranium or 3.5 million tons of coal. So while we cannot know for sure if alternative nuclear technology will keep its promises, shouldn't we at least do more research before we forego an opportunity to solve lots of humanity's current problems? It might not be an easy challenge, but that hasn't stopped us before. So, should we use nuclear energy? There are risks involved in any great human endeavor, and we have to make an informed decision rather than rely on gut feeling. If you want to hear the other side of the argument,
All right, so I find both those really interesting. And I totally, as I'm watching them, I'm like, yeah, that's a bad idea. And yeah, that's a good idea. So this is a really complicated topic and debate because there are definitely concerns and problems with nuclear energy, and there's definitely really strong benefits for them. So that's just something to be thinking about as we go through, as we continue, this continues to be an issue locally. I did want to talk about the dangers of uranium mining as well. So when mined, uranium ore has to be ground up and then mixed with an acid or alkaline solution so people can take out the uranium. The waste or tailings, as they're called, left over from this process consist of rock particles, water, chemicals, and radioactive contaminants like heavy metals. About 85% of the radioactive elements in uranium are remained in the tailings. There are 25 tailing sites across Canada as we produce 500,000 tons each year. And each of these, we have enough to fill the Toronto Rogers Centre, the Sky Dome, more than 100 times. So this is what the tailing treatments kind of look like in little lakes. Here what it looks like in real life. And here's just a picture of the Rogers Centre, the Sky Dome. To think about if we have 100 times of those toxic waste, that's a lot. That's a lot of waste. So tailings leach into groundwater and surface water, polluting water and the soil. And they also the wind carries radioactive dust and radon gas from the tailings. These pollutants affect wildlife habitats and human communities near mines and tailings. Caribou in northeast Saskatchewan eat lichen contaminated with radioactive materials, and the people who eat the caribou increase their chances of getting cancer at a rate of 6 new cancer cases per 1,000 people. Tailing sites need to be managed carefully forever because radioactive material do not break down for hundreds to millions of years. So this is just another added component of this debate. It's also true that for the waste for nuclear power plants, not just from the mining. So now you can answer the questions on page 112, question 1 and 2. Just considering the costs and benefits of those. Now we're going to look at the costs and benefits of other of renewable sources. So wind power. Ontario leads Canada in capturing wind power, at most of its wind power farms are located along the shores of the Great Lakes. Wind power is cleaner than nuclear power and fossil fuels, as its environmental impact is small and it requires very little land. Building a wind farm requires research and careful planning. Developers must consider a number of factors to make sure a potential wind farm will be economically viable by producing enough power to justify spending the money to build it. Developers research a site that has to meet their criteria. So there needs to be adequate wind speed. Wind speed and weather must be measured at the site for at least a year to find out if it's a good site. It must have low environmental impact. Wind farms should not have negative impact on the environment, so they need to pay attention to bird migratory paths, things like that. And they need to consider the hosts. The landowners in the wind farm area need to be willing to host the turbines. They will make a yearly profit if they allow the turbines on their land. So there's a sensible bottom line. It has to make sure that the wind farm must provide enough energy in its lifetime to offset the initial and maintenance cost. So then similarly, what are the hydroelectric power costs and benefits? So on a large scale, high impact hydroelectric power plants provide the second greatest amount of energy to Ontario's power grid while not emitting air pollutants, waste, or global greenhouse gases. So it seems to have a lot of benefits. They can have negative impacts, however, on aquatic and riverbank ecosystems, as well as human communities, which can be destroyed when a dam is built and an area is flooded. Building dams is really expensive, and water quality decreases as silt gradually fills up lakes instead of flowing downstream. Some suggest it would be better to build low impact hydro plants from now on, as they are smaller. With careful planning, they would cause only as much damage to riverbank and aquatic ecosystems as natural flooding, drought, and erosion would. Low impact dams contribute about 6% of Ontario's total power generation, so nowhere near as much as the high impact dams. So here is a picture of a low impact dam. It's not as dramatic as the dams that we've looked at previously. And again, these types of dams contribute to 6% of the electricity in Ontario. So they're not super impressive, but maybe we need to invest in more of those. That might make sense. So now you can answer the key questions on page 114, questions 1 and 2. So then another option that we wanted to look at are biofuels. So any vehicle that burns petroleum, diesel in a compression ignition diesel engine can use an alternative fuel source that's called biodiesel. Another biofuel can be used in gasoline engines, though there are conflicting opinions about it. Biodiesel is a type of biofuel made from plant and animal oils, fresh oils, or recycled, or from algae. It is made through a chemical process that separates glycerin from the fat in the oil. There's two products and both can be used. So methyl esters can be used for fuel and glycerin can make soap and other cosmetics. So we're going to watch a video about biofuels to just understand what they are as well. See if it works for me.
Biofuels. Biofuels are combustible fuels created from biomass. The term biofuel is usually used to describe liquid fuels such as ethanol and biodiesel that are used as replacements for transportation fuels like gasoline, diesel, and jet fuel. Ethanol is an alcohol formed by fermentation. It is used as a replacement for or additive to gasoline. Biodiesel is an oil produced by extracting naturally occurring oils from plants and seeds. Biodiesel can be combusted in diesel engines or blended with diesel fuel. Biofuels are grouped in 3 categories based on the type of feedstock used to produce them. First-generation biofuels are produced from food crops. For ethanol, feedstocks include sugarcane, corn, maize, and others. For biodiesel, feedstocks are naturally occurring vegetable oils such as soybean and canola. Second-generation biofuels are produced from cellulosic material such as wood, grasses, and inedible parts of plants. This material is more difficult to break down through fermentation and therefore requires pre-treatment before it can be processed. Third-generation biofuels are produced using the lipid production from algae. In addition, the term advanced biofuels is used to describe the relatively new technological field of biofuel production that uses waste such as garbage, animal fats, and spent cooking oil to produce liquid fuels. Biofuels are currently the only viable replacement to petroleum transportation fuels because they can be used in existing combustion engines. This is an increasingly important advantage with growing concern about the environmental impacts of fossil fuels around the globe. Biofuels can also help provide energy security in regions that do not have hydrocarbon resources but do have suitable agricultural conditions. While there is some dispute over just how renewable biofuels are, it is generally accepted that the crops used to produce them can be replenished much faster than fossil fuels, which take millions of years to form. Concerns about biofuels are usually centered around the fact that they are an agricultural product. Producing these biofuel crops can mean competition with other natural resources, particularly land, food, and water. First-generation biofuels use only edible crops, which has led to biofuel crops displacing food sources in certain regions and subsequent spikes in food prices. In many regions of the world, subsidies are provided for these crops, which only amplifies these issues. In addition, increased agriculture of any form comes with concerns of deforestation and biodiversity loss, as well as water and fertilizer use, which have environmental and climate impacts all to their own. That's biofuels.
All right, so that video gives us a bit of an understanding of what biofuels are, as well as the benefits and the concerns. So this chart that is in your workbook just shows you compares the petroleum diesel to biodiesel and the benefits in terms of that petroleum diesel is available at most places and it only costs 9.24 cents per liter, whereas biodiesel is available at very few retail sites in Ontario and British Columbia and costs $1 per liter. But petroleum diesel has significant environmental impacts and biodiesel has a significant reduced emissions. So that is definitely a benefit in terms of looking at environmental impact. But part of the concern about biodiesel is that food is being used to make fuel. And so therefore, as places like here, where the cost of food is already really, really high, if we're using our food sources to make fuel, how are we impacting on our marginalized communities? So just something that to be considered. All right, so that is our lesson for today. So we, as always, covered a lot, packed a lot in. So we've completed lesson 14, which is the costs and benefits of using various different energy sources. So we looked closely at natural gas and really in detail at nuclear energy and how these already have infrastructure set up and have higher energy return. So these are the benefits. So we already have everything in place. We don't need to build new things as much, though with nuclear energy, as we saw, there could be significant benefits to continue to develop the technology and invest in the development of it. And we get a high energy return. So we end up getting a lot of energy from these sources. But the costs are that they have high levels of pollutants and waste in both the extraction, how they get it out of the earth, and the actual use of them. Plus, they are non-renewable. And so once we use them up, we don't have them. And then even though we have the infrastructure set up for them, we've got all of our systems are set up to use them. If we don't have any of them, we can't use them. So that's concerning. Then we looked at wind and hydro as examples of renewable energy that have no emissions or waste. So the benefits of them is that environmentally they have little to no impact, and contributions to greenhouse gases and the climate crisis. So that's really beneficial. However, because we don't have a well-established infrastructure, we don't have a lot of wind farms, we don't have a lot of low impact dams that we can use that we've already established, we'd have to invest in the establishment and the construction, the development of these types of energy systems. So it's going to cost us a large amount initially, and we also don't get as much energy from these systems as we do from fossil fuels. So we feel like we need to invest a lot of money into it, and we're not going to get a lot of energy return. So that makes it really feel like, is this really the best option? Yeah, depends on what your value system is, right? And then biofuels is the final option that we looked at. Oops, sorry. And the pros are that it's more renewable than fossil fuels, though it is still consumable and something that we do need to maintain and plant and grow. It's just much more accessible to grow corn or rice or whatever, to opposed to hoping to grow more natural gas deposits, which takes millions of years. So yeah, so we can do this in a year, we can grow plants that we can then use for fuel. But in terms of the emissions, it has less emissions, but we still have to do more research about it. We don't need to change things because we can already use the systems that biofuels can already be used in systems that we already have established. So we're using infrastructure that we already have, which is beneficial. But also it's like, well, if we don't need to make change, does that mean that we're not making bigger changes? That means that we're just going to end up in the same place in 30 years or something like that. Is it maybe important that we actually make big change and invest in making big change to have long impact over the next number of generations and such? And then also the concerns about the fact that we're using food for fuel, which means that the cost of food is increasing and there is becoming not as accessible. Food is becoming a concern more and more for communities, and therefore the wealthy are going to have access to food because the wealthy always have access to things. And that's how our capitalist system is structured. That's where the power is. But those of us who are impoverished or who experience marginalization in various ways, so whether you are part of the global majority and a person of color, or you are experiencing poverty, if you live in remote areas, all of these things are having an impact on your accessibility to food and have an imbalance of power. And so if we're using the food to create fuel for everyone, including the wealthy who already have everything and they're putting the power in place in terms of what they're supporting, is this really setting everyone up for success, or are we just continuing to create an imbalance of power? So something to consider. So our success criteria, have you met them? Do you know the information in lesson 14? So you know the costs of extraction and the use of coal, natural gas, and nuclear energy. Of course, we didn't talk about coal too much today because we've talked about it a lot previously. You can explain the benefits as well as the challenges of wind, hydroelectric, and biofuel, as these are all sort of alternative energy sources that are being looked into and asked for more and more. That there are definite benefits, but what are the costs? What are the drawbacks? What are the challenges of these? As nothing is a perfect system. So you can do the review questions now on page 117, questions 1 through 15. So that is our wrap for today. If you have any questions, please reach out. As you're always welcome to connect with me, even though I am no longer fully responsible for this course. So if you want to email me at bronwyn.slate, and that's spelled BRONWYN.SLATE at nec.owen.ca, you can. Remember, all of our lessons are still going to be up on YouTube. All of those videos are listed under the supplementary videos, so you can still access them. You can share them. You can access them from their original sources and find more about these thoughts, as this is stuff that's really important to consider. It has a large impact on our communities, on our lives, So all that information is connected through my YouTube channel, which is under the name B-Slate Wahsa. You can call both John and I at the 1-800 number, which is 1-800-667-3703, and the local number, which is 807-737-1488. My extension, if you want to talk to me, is 2209, and John's extension, if you want to talk to him about any of your questions or any of your marks, is extension 2210. Also, his email address is jstradiottto@nnec.on.ca. And his hours are Monday through Friday, 8:30 a.m. to 3:30 p.m. and taking lunch from 12:30 to 1:30 and isn't available during that time. So please reach out to us if you have any questions and need any support. As always, thank you so much for joining me. I hope you have a lovely Thanksgiving weekend and a great break and enjoy, hopefully not just snow, but some sunshine as well. And we look forward to connecting again next week. Miigwech.